Welcome to the Explainer. So today we're actually going to do something a bit radical. We're going to completely shatter the illusion of objective scientific truth, and instead we're going to explore the absolutely awe-inspiring challenge of modeling the universe. If you've ever looked up at the night sky and wondered, hey, is what I'm seeing the absolute, unvarnished reality? Well, you're in the right place. Because we're going to dive into exactly why our conventional understanding of science might actually need a massive paradigm shift.
I mean, just look around you. We live in this seemingly seamless, continuous world, right? It feels incredibly real. But consider this for a second. What if our very biological, cognitive constraints fundamentally bar us from ever accessing the true thing in itself? The trajectory of modern theoretical physics has actually arrived at a pretty sobering realization. You see, the quest for objective reality isn't stuck because our telescopes aren't powerful enough or, because our particle accelerators just aren't big enough. No, it's hindered by our inherent anthropocentric limits. We are literally filtering everything through a very specific slice of existence, and that means we might never truly know the universe in its absolute form.
So here's our roadmap for today. We're going to cover 1. The epistemological barrier. 2. Continuous reality discrete tools. 3. Building reality lookalikes. 4. The physics Turing test. 5. The bridge, which is called the in-between. And finally, 6. Good luck to us humans.
All right, kicking things off with Section 1, the epistemological barrier, acknowledging our cognitive limits. We really have to begin by addressing the very foundation of our existence as observers. Why is our perspective inherently limited to just a filtered slice of a finite substrate? Basically, we simply cannot occupy a God's eye view. It's just not possible. And because reality is a finite substrate, we immediately run into a strict ground rule. We cannot and absolutely should not use the word infinity. True infinities? They simply don't exist in reality. Honestly, when they pop up in our math, it's usually a giant red flag that our model is breaking down, not that the universe itself actually contains something infinite. But you know what? That's actually a massive plus for us. The fact that actual reality lacks these infinities gives us a finite, workable baseline to start from.
Which brings us to a concept we have to embrace, called ontological modesty. Now, this isn't some failure of human intellect. Rather, it's just a baseline condition of our existence as biological entities. By humbly accepting that we can only ever create a perspective on reality rather than claiming we've identified the source itself, we kind of free ourselves. We can finally stop chasing this impossible objective ground truth that is, frankly, computationally and cognitively completely inaccessible to us.
Moving right along to Section 2, Continuous Reality Discrete Tools, or as I like to think of it, the great irony of modern science. This brings us face to face with a massive clash between the fluid universe we live in and the highly fragmented tools we're forced to use to actually measure it.
To put this into perspective, think of reality as a perfectly smooth, flowing river. Now look at our tools: numbers, computers, bits, nodes. They're inherently digitized. They are granular. We are literally trying to build a perfectly smooth, flowing river using totally square, rigid Lego bricks. We're taking absolute, non-fragmented existence and forcing it into these step-based, perspective-driven approximations. It's an overwhelmingly daunting task for modern science, to say the least.
So, that leads us into Section 3, building reality lookalikes, a true paradigm shift in simulation. See, because forcing a continuous reality into a rigid lattice creates these discretization artifacts, which are basically computational seams that break down fundamental physics, like violating Lorentz invariance. We have to make a massive shift. We have to move away from static laws and start thinking in terms of dynamic systems.
And to bypass those artifacts, we have to ask ourselves a genuinely baffling question. Can a discrete system actually manifest continuous physics? How in the world can we possibly simulate a seamless universe using only the fragmented language of math and computers? Like, how do we take these discrete engines and somehow make them behave exactly like a fluid reality?
Well, the strategic imperative here, and this is brilliantly outlined in the source literature, is this. We must stop asking if a model is right and start asking if it is indistinguishable from our experience. We don't actually need the exact truth. We just need to architect a digital twin that simulates observed behaviors so perfectly that it fully satisfies our cognitive constraints, all without ever claiming to actually be the source.
Which takes us to Section 4, the physics Turing test, validating the approximation. Because, how do we actually know if our digital twin is working? Well, it has to pass a grand test. It has to completely deceive a scientific observer into seeing familiar physical laws naturally emerge from the simulation. If it just stays a mathematical abstraction, it's a failure.
So these three established pillars of science, they serve as the ultimate benchmarks that our discrete model just has to hit. This is the ultimate so what of computational physics. First off, our discrete nodes must manifest the probabilistic wave-particle dualities of quantum mechanics. Second, they have to replicate general relativity's large-scale space-time curvature. And third, they have to naturally derive the standard model of fundamental particles and forces. If you can pull that off, it completely ceases to be just a simulation. It becomes a valid representation of our universe.
All right, on to Section 5, the bridge, the in-between, bridging the discrete and continuous. Now, achieving this emergence, especially for that second benchmark, gravity, presents an absolutely monumental mathematical hurdle.
We are faced with the awe-inspiring challenge of translating the resolution of a fragmented, step-based computational grid into the seamless, non-Euclidean continuous geometry of general relativity. And guys, this isn't just a matter of, oh, we just need a bigger supercomputer. No, this is a profound, fundamental friction of mathematics itself.
So to cross this gap, we require a radical, entirely new mathematical object, what's being called the in-between. It basically acts as the vital translator, taking the fragmented, rigid logic of our computer models and forcing it to manifest the smooth, continuous behaviors of the actual universe. It's what could finally allow those beautiful curves of gravity to naturally emerge from a totally digitized foundation.
And that brings us to our final stop, Section 6, Good luck to us humans, the ultimate intellectual endeavor. Let's see how all of this builds into what is quite literally the absolute pinnacle of human intellectual potential.
Attempting to build the real out of the discrete demands immense intellectual audacity. We are literally trying to engineer a functional mirror to the cosmos using fundamentally mismatched tools. So that phrase, good luck to us humans, it isn't just a passing sentiment. It's a very real recognition that, math-wise, we might be punching just a little bit above our weight class right now. The hurdles ahead of us are staggeringly vast.
I'm going to leave you with this final thought. The path forward is incredibly narrow, and the technical friction is immense. But you know what? This pursuit fundamentally changes what science actually is. It reminds us that while the true, continuous, objective universe remains forever hidden behind this epistemological veil, our power to mirror it, to architect a surrogate that perfectly aligns with our perspective, is for sure our greatest intellectual triumph. Our best hope for understanding the universe isn't in unmasking it, but in perfectly mimicking it. Keep questioning everything you see, and until next time, keep exploring the limits of your own perspective.